Alright students, I just want to do hopefully a quick video on circle segments, well, line segments in circles, and so let's briefly review the types of segments we have. We have chords, which we know have their endpoints on the circle. Radii, or radius, goes from the center of the circle to the circle, so it's that length there. And then the diameter, which is just double the radius, which is also a specific type of chord that happens to go through the center. And then we have tangent lines, and we also deal a lot with tangent segments. And remember, a tangent is perpendicular to a radius. And then our new one is secants. And secants are lines that intersect the circle twice. So think of it as a chord that you just extend on forever in both directions. And so we're actually going to talk a little bit about secant segments. So it's a segment of a secant. So let's take a look at some problems. And I want to look at some problems from the exercise on Juno that we did. So one of them was this one here. So it's 18. Well, it didn't have any numbers on Juno, but in the diagram below of circle O, chords A, B, and CD intersect at E. Now, what we learned is, and this was because of similar triangles, if I connect AC and BD, it creates two triangles that happen to be similar. And because the triangles are similar, their sides are proportional. This allows us to create this relationship where it's saying CE, this length, times ED equals AE times EB. Now remember, it's not addition, it's multiplication. These line segments are not necessarily congruent. They're not necessarily the same length. What we do know is that their products, if we multiply them together, are equal. So let's take a look at this problem. So I'm going to put in the values of the line segments, and I'm trying to find EB, so that's why I've labeled it X, and that's this line segment, EB. 10 times 6 equals 4X. Well, that's simple algebra. I can say 60 equals 4X, divide both sides by 4, and 15 equals X. So therefore, EB equals 15. Now, I want to double check that. So 10 times 6 we know is 60. 4 times 15, that also equals 60, so I'm good. And also notice, 15 plus 4, that's 19. 10 plus 6, that's 16. They're not equal in length. This chord is actually shorter, but we know that their products are equal. So when you cut the chords into two pieces, the products of those pieces are congruent. Let's talk about line segments that have at least part of it outside the circle. Now the red one is a tangent segment, AB, and the blue one, AD, is a secant segment. Now, unlike the chords where we are actually taking the pieces and multiplying them together, what we're going to do is take the outside piece and multiply it by the whole secant segment. And then for the tangent, the outside piece times the whole tangent segment. And for a tangent, that happens to be the same. Now when I label these, so I'm going to label CD, which is this chord here, X. That's what I'm looking for. That's the length I'm looking for. Now sometimes with these problems, they will give you this part and this part, and you'll look for this, or sometimes they'll give you the whole length, and you'll have to find something else, maybe the outside part. So just be careful with what they're asking you and what they're giving you. So here, and I bracket this so I can tell that this whole length, AD, is X plus 4. Remember, to find the distance of something, I'm going to add them together. So this whole line segment, AD, is X plus 4. Now, if I know AB times AB, which is the outside segment times the whole segment, equals AC times AD, or I could rewrite that as AB squared equals AC times AD. What is AB? Well, it's 8. So 8 squared equals 4, which is the outside, that's AC, times x plus 4, which is the whole length of the line segment. 64 equals 4x plus 16. Do not forget to distribute the 4. So 4x plus 16, which is 4 times 4. How do I check that? Well, what I usually do is I put in a very little number here for x, like 1 or 2 or something like that. So if x equals 1, 1 plus 4 is 5. 4 times 5 is 20. Okay, well, let me check that down here. If x equals 1, 4 times 1 is 4, plus 16 is 20. All right, well, that still works. All right, so I know I'm good. So let's take a look at this equation then. 64 equals 4x plus 16. If I subtract 16 from both sides, then all of a sudden I get 48 equals 4x. You divide both sides by 4, x equals 12. Therefore, CD equals 12. Now I want to check that. Now to quickly check that, if CD is 12, then I know the whole length of the line segment is 16. So 8 squared must equal 4, which is the outside, times the whole length of the line segment is 16. 8 squared is 64. 4 times 16 is 64. Check. We're good. All right. Well, I hope this helps, and please let me know if you have questions.